Hey Pre-Algebra, welcome to online learning. So today we are going to be doing our first online lesson, and before we get into the math of it, I just want to go back to Schoology real quick and point this document out to you. So from the main page here, the online learning plan document, that's the same handout I gave you in class, but just in case you misplaced it by now, it's also on Schoology, and it outlines everything for online schooling, including your weekly schedule that we'll be following each week. We may have slight deviations from this schedule depending on how quickly or how slowly we move through material, and that's okay. Just watch Schoology to stay up to date. If you go to the very bottom of this document, you're going to see where it says everyone. I've got my phone number listed there. Feel free to text or call if you have any questions, and then also my email address. That's probably the best way to get a hold of me. Just send me an email at that email address. And again, my official hours are from 11:30 to 3:30, and I actually extended that from 11 till 3:30. So feel free to get a hold of me really at any time, but if it's during that time frame, I'll try to get back to you even faster. If it's outside of that time frame, I can't guarantee that I'll get right back to you, but I will get back to all of you. All right, so let's get to it. The first thing we're going to do before getting into the new material is this would have been a warm-up in class. This is just a slight review of what we were doing before spring break. So this is talking about domains. So remember, a domain is the set of x coordinates. The set of x coordinates. And I am writing with a mouse, so if I write anything and you're like, what does that say? Feel free to shoot me an email and I'll get that fixed. So it says, is the domain of this graph discrete or continuous? Well, remember, a discrete domain is a set of inputs or x coordinates that contains only certain values. The key there is only certain values in the domain. So that is for a discrete domain. It has only certain values. On the flip side, the continuous domain is a domain or set of inputs or x coordinates that has all values in some interval. So the difference is having only certain values versus having all values. So this graph right here, it starts for the x coordinates, because we're just talking domain, starts at -4. That's the x coordinate at this point, because this point is at -4, 2. And again, we're talking domain, so we only care about the x coordinate. And it goes up to this point, which is at 1, 3. And again, we only care about this 1 because that's the x coordinate, and the domain is just the x coordinates. So this graph goes from -4 up to 1 for its domain. So is it discrete or continuous? Well, do we have only certain values between -4 and 1, or do we have all the values between -4 and 1? Well, just imagine if you were to drag like a cursor along here, and if it could tell you the coordinates to every single one of these points, you would have every single number. You're not skipping any number between those -4 and 1 x coordinates. You have every single number. So because of that, you do have all values, and therefore it is a continuous domain. So I'm going to say, let me type this so it goes a little faster. So I'm going to say this graph has a continuous domain because it has all x coordinates from -4 to 1. And again, it would be discrete if it had only certain values. So if it was a graph that looked something like this, where it was, we could use the same x coordinates. Let's say you're going from -4 to right here up to 1, 3. And let's say we only had a few different points throughout there. Well, that would be discrete because we only have certain x coordinates. They're countable x coordinates. Here we have every single conceivable value between -4 and 1 for the x coordinates. The fractions, everything between the whole numbers, including the whole numbers, we've got them all, and that's why it's continuous. All right, so that is just a little review of what we did before spring break. So let's get into the new stuff for today, and that is 4.4, comparing linear and nonlinear functions. So we are still talking lines and basically non-lines. So what makes something a line? Well, lines have constant slopes. So if we're going to have a constant slope, then it's linear. If we don't have a constant slope, then it's nonlinear. So which one of these represents a non-linear function? Well, that question is really saying which one of these tables does not have a constant slope. So hopefully you remember from class to find a slope from a table. It's really the rise over the run So the slope is rise over run. Now, how do you find the rise and the run from a table? We don't need to graph this. That would take way too long. The rise is the change in the y-coordinates. So change in, let's put change in y. The change in the y-coordinates. The run is the change in the x-coordinates. Change in x. So from one y-coordinate to the next, how much are you going up or down by? Well, on every single one of these, from 6 to 3, 3 to 0, 0 to negative 3, you are losing 3 units. Subtract 3, subtract 3, subtract 3. So that is constant. So far this looks linear. Let's see what happens with the x-coordinates. So from negative 5 to 7, 7 to 19, or 19 to 31, what do you have to do to get from one number to the next as we go from the left to the right? Well, from negative 5 to 7, you have to add 12 to get from negative 5 to 7. From 7 to 19, again, add 12. From 19 to 31, again, add 12. So on this one, the rise over the run, the slope, remember we use m for slope, is negative 3/12, or if you simplify that, you get negative 1/4. So is that one nonlinear? The answer to that is no, because it has a constant slope. The rise over run never changes, so this one is linear. So the question does not ask you which one is linear, it says which one is nonlinear and why. But just to make a point, I'll say this one is linear because it has a constant slope. Has a constant slope. So assuming one of these is nonlinear, it's got to be this one, but let's prove it. So from one y-coordinate to the next, what's happening here? Well, we're adding 3, and then all of a sudden we are subtracting 10. With the x-coordinates, we are going up by 4, we're adding 4, and then we're going up by 3, adding 3. So here, the rise over the run, the change in y over change in x, the slope is 3/4, and then all of a sudden it turns into a negative 10/3. So at one point on this graph, we're going in a positive slope direction, and then all of a sudden we change to a negative slope direction. So can you make a line where the slope changes? Obviously, no, that's impossible. You have some kind of curve. So this one is nonlinear, and the reason for that is it does not have a constant slope. Again, sorry, I'm writing all this with a mouse, so bear with me. All right, so that's your first example. Linear versus nonlinear. Linear has a constant slope. Nonlinear does not have a constant slope. All right, so this one is a word problem. It says this equation, y equals 2x plus 3, represents the cost of buying used video games at a large indoor rummage sale. So this equation represents the cost. So y is the cost. This expression is the cost, and they're equal to each other. Y is the cost. X is the number of video games. And then we're going to find the total cost if we keep plugging in different values for X. So the question is not asking, does it have a discrete domain or a continuous domain? It's separate from that. I know we did that as the warm-up, but this is separate. This says, does the equation represent a linear or nonlinear function? So you have to be careful with these questions. This one is linear versus nonlinear. It has nothing to do with the domain. So is this linear or nonlinear? Well, if it's an equation, the question becomes, for it to be linear, the question becomes, can you write it in slope-intercept form? Can be written in slope-intercept form. And I know some of you, a lot of you, know what slope-intercept form is, but just as a review, I'm going to put it down here. That is y equals mx plus b. So if you can write it in this form, every single line equation, every linear equation can be written in the form y equals mx plus b. So if it's nonlinear, you can't write it in that form. So is this one already in that form? Well, yeah, it's y equals mx plus b. We have a 2 for our m, our slope, and a 3 for our b, which is the y-coordinate of the y-intercept. So this equation, y equals 2x plus 3, is a linear function since it is written, I should have typed this out, since it is written in slope-intercept form. slope-intercept form. All right, so let's move on to the next one. Using this same idea, it's going to ask us which one of these are linear. So which ones are linear? And there's definitely more than one here. So again, to be linear, to be a linear function, it has to be able to be written in y equals mx plus b. Notice I'm saying the words it has to be able to be written in y equals mx plus b form. It doesn't necessarily have to start in that form, but if you manipulate the equation, can you get it into that form? If you can, then it's linear. So this one, it's already in y equals mx plus b form. So that one is linear, so I'm going to circle that one. This one, if we simplify it and we distribute the 4, we get y equals 4x minus 4. And again, this is y equals mx plus b. So I could put, if it helps you visualize, I could put a plus a negative 4, which is the same as 4x minus 4. So it is y equals mx plus b. So I can circle this one. That one is linear. This one right here, a little bit tricky, but I could write this as y equals 0x plus 4.7 because I don't have any x's. So 0 times x is just 0, so this would simplify to y equals 4.7. So yeah, that's also y equals mx plus b. You can write it in y equals mx plus b form, so that is linear. This one, well, this is a pi symbol. Pi is a number. It's approximately 3.14. Pi is a number, so this is y equals mx. But then what's out here? We've got nothing out here. So, okay, put plus nothing, plus 0. So that is y equals mx plus b. So that one is also linear. The only exception here is this equation. This is not y equals mx plus b. This is y equals 1 over x times 2. You could put a plus 0 on the end of that, but 1 divided by x, oh, I suppose I can put this the other way around. Y equals m almost x plus b. It's close, but this is not y equals mx plus b. This is y equals a number times 1 over x. This would have to just be an x, and there's no way to just make this an x. It's 1 over x. So this one is nonlinear. So this is not y equals mx plus b. It's close, but it's not y equals mx plus b. So that one is not linear, so I'm not going to circle it. All right, moving on to the next one. Does the graph represent a linear function? Well, the root word right in there for linear is line. So is this a line function, a linear function? Well, does it look like a line? Telling if a graph is linear or not is that easy. Does it visually look like a line, meaning does it have a constant slope? You can tell this one does not have a constant slope. So this one is not linear. So I'm going to say, does it represent a linear function? Let me type this one out. The graph, I'll shrink that down a little bit. The graph does not represent a linear function, since you could say since it does not have a constant slope, or since the graph is not a line. There's a couple of different ways to explain it. If it's a graph where you can visually see the graph, you can say since the graph is not a line, it's not a linear function, or you could say since the graph does not have a constant slope. And if you explain it this way, then you're explaining it the same way as you would with a table. For nonlinear, does not have a constant slope. For nonlinear, again, does not have a constant slope. And this is a perfectly valid explanation as well. All right, so that's it. That's all I had for this lesson. So your homework, your first online schooling assignment that I'm assigning from Schoology is page 174 all. And again, I will have this posted, this book assignment page posted to Schoology. So if you forgot your book or if you don't have your book, look on Schoology and you will see this assignment right paired with this video. So if you have questions, contact me. Otherwise, remember to turn your assignment in on Schoology. Don't send it to me in an email. Try to keep everything on Schoology. All right, thanks.